Hello everyone, my name is Scott Bates and this is going to be part 2 for graphing skills with line graphs. Now, this is probably the harder part of the lab itself just because of some of the post-lab questions, and also graphing the line graph seem to be a lot of students struggle with that as well. So before we get started, I wanted to give you a little cool tip. So if you notice in the bar graph and histogram section there, you have to put the dependent variable and independent variable, and the students need to know how to do that. And hopefully you've heard of this acronym before. It's a really awesome acronym. I literally will just yell this to my students all the time. But the acronym is, if my camera work, is dry mix. So it's a capital D, lowercase r, uppercase y, and then it is a lowercase m, uppercase I, uppercase x. So it is dry mix, which stands for dependent responding y-axis. The mix stands for manipulative independent x-axis. And as you can see, with just how the capitalize is, my students will just remember actually that IX part, independent x-axis. And so they know whatever's on the x-axis is the independent variable, and whatever's on the y-axis is going to be the dependent variable. So this is what I actually just write this on the board because I say it so often when the students know repetition, and they will, and like I said, they can usually figure out which one's on the x-axis, which one on the y-axis, but they always seem to struggle, even though you may say, well, independent variable is always on the x-axis, but this acronym really helps. So anyway, that's a good tip for you. Let's go ahead and go to the next section. So with line graphs, you are definitely going to need to walk through a sample graph with your students when you're doing this, because here in number 3, in the directions, there A through G right here is an amazing tool. It has everything you need to do for a perfect graph. And I'll actually, in my classroom, I actually always have a student write these on easel pad paper with the brief descriptions, and I leave that up just about all year. And it's some great to reference, and I love the vocabulary in it. Like, talking about, the scale units, that's a big one. We want to make sure that graph is completely full and making sure you're picking the correct scale and stuff. I'll say in my class, it just depends on the class. Sometimes I will have I'll have an example ready, some data, or I'll actually go to the problems and pick one of these and graph them. So let's go ahead and get started. And again, keep this in mind when you turn in your graph, or when you put the picture of the graph. We're going to be looking for all of these things just like we would to our students. So with this part of the lab, you actually have to graph 3 separate graphs. Sample data set 1 right here, it's a time position graph. And this is something that it's easy to forget. The title of the graph, it actually tells you in this description, the dependent variable goes first, the y-axis, and then the independent variable goes second, the x-axis. So, of course, instead of saying time position graph, we all know it's a position time graph. Position's the y-axis. Mass volume graph, and then percent transmittance per time, whatever. But you have 3 different graphs. So when you're graphing these, this is where you're going to actually insert them. So sample data set 1, you have 5 questions. You're going to insert the picture of sample data set 1 graph right here. Put it right here above these questions. Same thing for number 2, sample data set 2, put the second graph here, and 3, put it right here. Now, I just want to go over just something I noticed while doing this lab. I'm going to talk about mainly these 2 right here. So, pull my graph up. Okay, so here's the thing. Like I said, please make sure you refer to A through G, and that's number 3 direction. So you do have everything in your graph. Now, when I'm doing this with my students, I do tell them it doesn't matter how big it is, but I tell them it's however big they think they need to make it, and to where they can see that information. because again, the goal is they already have the information. They're just trying to make it look more, I tell them, prettier, so they're actually able to easier read information more accurately. And as you can see, I'm using a ruler and graph paper, making it pretty straight. Now, I'm not going to talk through every little thing you need to do, but I'm just going to show you something that it happens more often than not when I do this lab with my students. And that is, so they're usually pretty good about the left being the x-axis and the right being the y-axis. They're usually pretty good about that. And again, when you're doing your graph, you need to make sure when you turn it in for this grade, you do label your x and your y-axis. And also make sure you include the units. You can use abbreviations if you'd like, and I tell my students that too. But please make sure you include units. Now, like I said, this graph is this long, this big, and you notice I got 0, 5, 10, 15, 20, 25, and I could easily go by 5 here. And I could actually, with how graph is, I could probably skip like a box and make it completely fit the line, which is great. It's very easy to do, and it looks kind of full when I do this. So there is a little bit of a section here, but majority of the graph is full. And then right here, this is where my students will make mistakes, or not all of them, but a lot of them will. So the scaling for the y-axis, I have a select group of students that will just put, instead of putting what they should here, instead of going by a particular scale, they'll actually just go by this right here. So then, they'll leave 0 there, and then they'll put 15, 30, 45, 60, 75. Now, and all the way up, whatever. But the problem is, this is actually correct because it does go by 15s. But if the Y data was like this, they would actually do this: 2, 5, 7.5, 16, 24. So the scale is just going, there's no scale. They're just putting what this is. And so it's like a false sense of insecurity, or a false sense of security with this first graph, because it's perfect. It goes by 15s. They can easily just follow along and do it. But then they come to this one and they think, I'm going to do the same thing. And when I first taught that lab, I guess I wasn't clear enough when I didn't even know that was going to be an issue. So you need to be very careful about that and make sure that your students pick an appropriate scale. Like for this one right here, the lowest is 2, the highest is 24 for the y-axis. So you might go by 2s if you would like. You could go by 3s. You could go by 5s. You can go by whatever, but you just need to make sure your students are going by the same number. That's the biggest issue I've seen with my students, and I've heard from other teachers from previous trainings. And this volume, the x-axis, will get a lot of students as well, because they don't realize they can go by numbers below 1 sometimes. They don't. I was like, well, I want to go by 1s. Well, if they go by 1, they got three dots, and they're already past the x-axis. And so the thing is, once I say, well, you can go by, a half, 0.5 or whatever, and they're usually pretty good. They'll hopefully figure out you can go by 0.25, which I think is the majority for this one for me. But that is some issues. And also another issue that I've noticed, again, is sometimes my students will actually do the first point and put 0 for the first point. They don't, and I've seen that mistake a lot as well. So they don't realize that the origin is 0. And again, this is done very early in the year. They may have just had a really good summer, completely forgot about graphing. You know how it is. But it's just kind of like once you do this lesson and you're hitting all these points, it's just kind of like, okay, I remember all this stuff now. I'll be good. But like I said, the biggest thing to worry about just from data set 1 to 2 is, so they can easily go by 15s or go by 10s here. But if they go by 15s, they're putting the exact thing. They're going to come here. And I have always a select group of students that will do 2, 5, 7.5, 16, 24 for their y-axis. So Please be very careful. And again, when you're doing your graph, think about, like I said, try to make it as neat as possible. Make sure you have that X, that Y axis labeled. Make sure you put that title. And remember, it's the dependent variable versus the independent variable, the Y versus independent, Y versus X, and so on. So be very careful about that. Now, another thing, you actually are going to do a best fit line for these graphs. Now, I'm not going to graph this full thing, but it should look like something very similar to this. It's going to be like a straight line almost. I mean, obviously, it's going to be a little bit better for you because you're going to hit the actual corners. But when you're doing this, students, so at this point, sometimes they get frustrated with the rulers, and some do, and some just love using it, and they're just killing it. But I do have students, and they always try to do it, and I'll mark off points as soon as they try. That best fit line or that straight line or the whatever line you have, you need to make sure you use a ruler and make it straight as possible. Now, again, mine's not perfect data, but technically it will go through the origin, and notice how straight that line is. And a lot of them will just stop right here at the last dot, which I tell them to actually go past that, because, and you're going to see in the questions, they actually have to predict, where would the y-axis be at 30. Well, they could actually use their ruler and make little dashes. Like this, I'm just going pretty quick, and they can actually see where that point is. And they actually love making these dashes. Again, you walk them through it just a little bit, and you show them how to do it. And if they use that ruler, it makes it so straight, and they're actually really impressed with the work they did. Because again, this is probably one of the first times, unless they did this in 7th or 6th grade, to where they use a ruler and you're asking for very specific information on a graph. And so they really enjoy it, for me, very surprisingly. And it's also at the very beginning of the year as well. It's when it's supposed to be taught in the A+ curriculum. And, they haven't maybe opened up in their shells yet, so you're actually able to get a lot of stuff done. So I'm just going to briefly talk about these questions right here. So again, you're going to make sure you put, sorry, I forget to mention this. For data set 3, the percent transmittance, as you can see, there's 4 points. The students really struggle with that scaling as well, because again, the hardest part, they only have 4 points, but they have to fill that whole graph, and it does get them a little bit, because, and I will actually show you a little example of what I'm talking about real quick, and then I'll talk about the questions. And this is what you don't want to see. And again, if you walk them through one of these graphs or a sample graph, and you say, this whole graph is full, it's perfect or whatever, they're fine. But if you leave them to their own devices, they may use the wrong scaling for the x-axis. They'll go by too big of a number, or they'll go by too little of a number, or it's usually too big of a number. And so their top number is right here, and they have it perfect on the x-axis, but when they do their line, it's like something like this. And as you can see, all of this is not used, and it just depends on, sometimes the thing don't even make it here. It just stops right there. And I know y'all have seen that before too. So you need to really push the scaling factor, and that is the biggest. I think that's probably the hardest part of this lab, is figuring out. And again, I try to let my students negotiate that and figure it out, and everyone would usually have a different scale, because some people will go by, for this one, for instance, the volume, they'll go by 0.2. Some will go by 0.25. Some will go by 0.5. And you could even do 0.5. It would be kind of a smaller graph, but I've seen it work. But again, and even then, when a student does a 0.5 graph versus a 0.2 graph, I will compare them, and I'll let them bring their graph up in the document camera, and I'll say, okay, which graph looks easier to see, what's better to see, and they'll always say, that the 0.2 graph because you're actually able to see the information a little bit better, and they're starting to understand. Picking the appropriate scale is what really makes the graphs look very clean. It's not saying that 0.5 is incorrect, but 0.2 you'll actually be able to see a much better graph, or 0.25. Now the questions, again, it's great questions again, and it actually has some prediction questions where they actually have to look at the graphs, and they have to, like, and this is something that you also got to show us, like, we can just find 2.5 on the graph and go up, and they're just kind of following lines and stuff. Now you do have to calculate slope on an equation of a line. That is can be tough for them, especially considering how 8th grade students can be at the beginning of the year. They may say, "Oh, we didn't learn slope," and they may have not learned slope. They may have. There's just no telling. Their teachers didn't teach them graph. Again, all these excuses. You have no idea. But the thing is, when you're talking about slope, I found it easier to always include the units with slope. So, because when you do slope in math, there's not really, they know it's a rate, but sometimes with all the math problems they don't have units. But obviously with our graphs, we do have units. So right here, time and position, when you're finding slope for just the first section. Again, if you need to remember the formula for slope, it's changing y over changing x, or y2 minus y1 over x2 minus x1. Pick two ordered pairs, x1, y1, x2, y2, and you just plug those numbers in, making sure you keep the 2's above each other and the 1's above each other. And I always say, put those units down, and they know this is a position time graph, so it's going to be meters per minute. And so whatever answer they get, let's say they get 6. So it's like, oh, you got 6 meters per minute. What does that sound like to you? And it's like, well, meters is a distance, minutes a time. So, and it's kind of funny because the answer for that one is like, it's like 3 meters per minute or something. It's it's a pretty good distance for a minute. And I'm like, what type of animal moves that slow? And when you put that into reference with the students, they actually start, oh, slope's just not slope. It actually does something. And so it kind of brings it alive. Now, the equation of a line part, you might have to really walk them through that. That is something that even if they did learn that last year, they forgot it. And they really, and you can really touch on that, but that part is hard to bring home with this part of the lab. And again, these questions do a really good job. And again, like part 2, they have to do equation of a line again, and they can plug it in. And it's really cool because they can see the math part, but you could also look at the graph as well. And so this is just some really great questions because it asks the meaning of, the data that they've just graphed. And again, when you teach this lab, bring home that you already had all the information. These tables are everything you need. You don't need anything else. But how could you actually read the tables and answer the questions as easy as you did with the graphs? With those graphs, they were able to see it. They were see the numbers. They can use the rulers to go up and down. They can say, and that's the bring it home is like. And so instead of seeing graphs as another obstacle that they have to do to get credit, a graph is actually a tool they use to help better answer their questions. And that's also one of the main goals of that. So hopefully you enjoy this lab. Make sure to have really neat, clean graphs. Again, think about what you want your students to turn in. And I'm not even joking. If you walk your students through this lab with a ruler and everything, you really will get absolutely spectacular looking graphs. I'm talking like the students will be extremely impressed as well with their own stuff. Please refer to this when you're doing your graph A through G, because that's what we're going to be looking for.